Welcome back to Medical Statistics, in which we are talking about using statistical software and summarizing data today. This section is going to cover statistical software packages in which we are going to talk about what actually are statistical software packages used for data analysis, entry, and whatsoever. We're also going to talk about what do these statistical packages do and how do these statistical packages work. We're also going to talk about how to transfer data between different statistical packages. So let's start off with the introduction of a statistical software package. So statistical software package, also known as statistical analysis packages, is actually a software program which consists of different commands and different processes which can be used to carry out manipulations of the data, analysis of the data, or you can also simply do data entry as well. So that is what statistical software packages are and what they're used for. One good thing about these packages are that they are made in such a way that they provide a user-friendly interface. And because of that user-friendly interface, individuals like me and you who do not know a lot about statistics and who are not expert in statistical programming, they can also use these simple statistical software packages to carry out their own data entry, their own data analysis, and statistical problem solving. Here, if you look at this picture, is an example of such a statistical software package known as SPSS. Now the question is, what do these statistical packages do? So they can be used as data entry, such as the most simplest form of such a package would be Microsoft Excel, in which we can simply enter the data. Data management, data analysis, like for example, calculating means, medians, averages, interquartiles, comparing different groups, performing tests of significance such as independent t-test, doing normality analysis. So all of those things that comes in the data analysis, and even if you're not a statistical expert, you can perform all of these tasks yourself using a statistical package. And at the end, data presentation, such as in producing graphics in the form of graphs, figures, plots, and pie charts and all of those things. So you can also make all of those things yourself using a statistical package table for it. Now the question is, how do these packages work? So there are two different ways in which these packages work. So there are menu-driven packages and there are command-driven packages. I personally prefer menu-driven packages, and why is that? We're going to look at what menu-driven packages are in the next slide, and maybe that can be obvious. So menu-driven packages are just like any simple computer software program, and anyone with basic computer knowledge can use this program or such a program. And one of my favorites is SPSS, and that is also based on a menu-driven package. So in a menu-driven package, it provides options for the user to select in menus that are usually in a hierarchical design, such as in a simple software such as a Microsoft Word, in which you click on File and then you click on Save As. So you give commands by going into hierarchical windows. So similar is the case here in these menu-driven packages, such as I gave you the example of SPSS. For example, here the user clicked on Utilities and a drop-down menu appeared, then he clicked on Custom dialogues, and options keep on appearing, and the person can perform any type of data management or analysis just by clicking on these windows and hierarchical buttons. Moreover, it also has the advantage the user does not have to remember commands or computer syntax language. So you don't have to remember anything. You just need to know, okay, I want to analyze, I just click on the analyze. I want to make graphs, just click on the graphs and select the suitable graph and setting, and then just you are done with it. The drawbacks to menu-driven packages are that they can be slow because especially if there are no shortcuts through the menu system, and it may be difficult to find the right menu if you are new to it, but once you get used to it, that is not much of a problem. But it can take a little bit of time because you have to click on one button and then go into menus and submenus to find out the suitable command that you want to give the program. On the other hand, there are command-driven packages, and I think they are a little bit more complicated for those people who do not know how to give commands to softwares and computers and who do not understand the functioning of syntax. So they work by the user entering a particular command, which will execute the required process or statistical method, similar to the way people work on my MS-DOS, for example. It is usually quicker than using menus, but the drawback is that it does require the user to remember and enter the actual commands. And if you do not know the commands in the syntax, you would not be able to carry out the analysis or the commands. If the syntax is entered incorrectly, for example, with a typo or a typing mistake, the command will not run, so you need to remember the exact command or syntax. And with the command-driven programs, or where a menu-driven program produces a copy of the commands as a syntax file, such as an SPSS, which is a menu-driven program, but it produces the copy of the commands as a syntax file as well. An analysis can be set up once, and then it can be copied and it can be pasted and used again for repeated implementation if you need the same set of analysis several times. So you can do that again and again by giving the same command. Now, using a package. So using a package enables us to perform complex calculations easily, which we are otherwise not able to perform ourselves, or it would take a lot of time. For example, there are 200 participants in our study and we have to calculate the mean, so we would have to add all of the values and divide by the total number, so it may take a lot of time. But if you have a package, you just click on one button and it gives you the required result and averages within a second. So it enables us to perform complex calculations pretty easily. Moreover, it facilitates the statistical analysis previously impossible, because if you have lots of data and lots of analysis, it can help you with that in a very short amount of time and in a very easy manner. But there is, however, a danger of conducting inappropriate analysis, because it would give you result no matter what command you give to the software. So it may give you some result, but sometimes you are conducting inappropriate analysis. You are not applying their tests, for example, an independent t-test in a right manner. So that can be a danger, and that is a drawback as well. Packages make it possible to use statistical methods we may not fully understand, and thus we can use wrong tests, wrong processes for wrong analysis, such as using parametric test for non-parametric data or skewed data. So that is an example. Using a package can also result in a vast set of results that have no logical thread, and we may just get carried over with that, and we may start doing analysis which are not required or which are not making any sense, and we can shift our focus from the thing which actually matters in the terms of results. Now, sometimes it happens that we have done data entry on one data, or we were analyzing data on one software, and we then just decided that, okay, I need to perform this specific test or analysis, and this software can do that for me, but I have to transfer my data from this software to this software. So that can sometimes become a headache and a problem. So transferring data between packages is a concern for every researcher. So we sometimes need to transfer data files between packages or between computers. And the problem is that statistical packages often store data as a coded file that can be directly transferred from one program to another, but that is not always the case. So when you are not able to transfer data from one software to another, and let's suppose you want to transfer a file from software A to software B, but software B does not support that format, so that can become a problem. So how can you do that? There are a few solutions. So first of all is to create an export version of data within the package. For example, I'm using a statistical package. I can use the command of save as, and I can save that file in a command which can be opened by another type of software. But not all packages can do this, and not all packages can do this for every other package, so that can be a problem. Another way to do it is like using or getting the data from spreadsheets. Like for example, if I give an example of Excel, there are spreadsheets there. So you can copy the data from a spreadsheet from Excel and paste it into the spreadsheet in the SPSS. But the problem is that the data may become affected by that, because sometimes the variables may change their nature, and a lot of problems can arise in that. And this procedure is mostly not recommended, but if you are doing it, be very careful with that. The best way to do transferring between different packages is to use a data transfer program such as stat or transfer. So what these programs do is they take coded files from one package and they transfer directly into a format which is eligible for opening in another package or software. So using a transfer program will usually mean that variable names and labels are also transferred, unlike copying from a spreadsheet or any other procedure. And that is why they are better, and there is not a chance of affecting your data, and it is the most safest way and easiest way to do it. Now, what are the potential problems that can arise in transferring data? First of all is there can be missing data, and that can be based on how are these handled in the transfer, such as if you used the technique of copying from a spreadsheet, so there is a risk of missing data, and perhaps that transfer method did not work out properly. Now, data format. You have text data transferred properly and are in the right format. For example, if you are copying names from Microsoft Excel to SPSS. So you should first of all make sure that when you're copying into the into the SPSS, the variable nature should be in the string format, because names would not copy into a numeric format. So have numerical data transferred correctly and are in the right format as well if they have a specific coding. So is that satisfied? So always perform a double check for that. And versions of the programs, like for example, you notice that for a certain software, new versions keep on coming, and sometimes it happens is that when you save a file in new format of the same software, it is unable to be opened in the previous version. So that is also a concern. So be careful when saving a file that it should be in such a version that can be readable by most of the softwares when you're working with it. So that was all about the first section of this lecture. I hope you learned something new out of it, and keep on watching sqadia.com for more lectures like this. Thank you very much.